Our problem statement is, does Mann Ki Baat affect discussions on Twitter? So first of all, here we have imported some libraries and initialized some variables. So for the data collection part, we have scraped our data from the official Mann Ki Baat website, which is from pmindia.gov.in, and it was annotated in English, so we could find those data and we scraped it and saved it in JSON format. Then we did some pre-processing on this data and converted it into CSV format. Then we performed ETL, which is extract, transform, and load process, which is mainly removing punctuation, special symbols. It might be removing or replacing contradictions with their full forms, and other things like removing numericals, etc. So we have cleaned everything, we have converted everything into lowercase, and we have performed a stemming process to remove all the unnecessary words from the raw text. So now it has become more usable. We have similarly collected data from Twitter for a 2-day period, which is 48-hour period for each Mann Ki Baat episode. So so this was collected using the official Twitter API, and we have done the same ETL process on this data also. One thing we also had to do is remove other languages here. So some Hindi words were there, so we extracted only English words. So next comes the EDA part, which is exploratory data analysis. And we have done this both for Mann Ki Baat and Twitter. And for Mann Ki Baat, we have used word frequency, which is bag of words model. And you can see that we have found the top 10 words. And we have plotted it. You can see these are the words. We have obviously removed some stop words which are irrelevant. This is for Mann Ki Baat data, and we have performed POS tagging on Mann Ki Baat data, which can be thought of as part of speech tagging. So we are trying to understand what parts of speech does a good speaker use in speeches like this. So you can see this is the distribution, and the full forms for all of this is on the official website of TextBlob, which is a library we are using to perform POS tagging. And for Twitter data, we performed language tagging. So what languages exist in these tweets, and what kind of special symbols we found. We have performed all of that, and we have categorized into English, Hindi, hash means hashtag, and mention means @ username. So these are the 4 things we visualized for all the episodes. It might not be visible, but this is for each episode. We are seeing the 4 parameters, and we have done word frequency, which is bag of words model on Twitter data, and we took the top 30 words, I believe, and plotted it, and you can see the distribution is exponential. So similar to the Mann Ki Baat data, there also the distribution was exponential. So our main objective now is to understand whether there is a relationship between Mann Ki Baat data and Twitter data. For this, we are using hypothesis testing. As you saw from the visualization, our data is not normal. Both the data are not normal, so we cannot use parameterized tests. So we have to use non-parameterized tests. One of such tests is Mann-Whitney U-test. So Mann-Whitney U-test is a non-parametric test which is very useful for our use case compared to other non-parameterized tests. So for our hypothesis testing, we considered two hypotheses. So first one is null hypothesis. So our null hypothesis is the relationship between Mann Ki Baat and Twitter data is purely by chance. And our alternative hypothesis is that there might be some relationship between Mann Ki Baat and Twitter data, and this has to be further studied using machine learning techniques. So we have used two machine learning techniques. First one is our unsupervised testing, machine learning. So before that, if you want, you can see the results of our hypothesis testing. So our p-value was 0.007. So since our alpha considered is 0.05, it's less than that. So we are rejecting our null hypothesis, which means that there might be some relationship between Mann Ki Baat and Twitter data. We have to study it. That's why we are using machine learning over here. So first machine learning model we are using is LDA. So not to be confused with linear discriminant analysis. LDA is Latent Dirichlet Allocation. So it is a type of topic modeling. It is more of a statistical method. It comes under unsupervised machine learning. So it categorizes or finds the topics in our text. So what does topic exactly mean in this context is topics can be thought of probabilistic distributions over words. So whatever words relate closely to each other, they become a topic. And you can see for we have plotted for a few episodes. So what are the topic? So here they talked about vaccine, and here they talked about medicine, so and so on. We did it for a few episodes, 5 episodes, and so this was our main outcome of topic modeling. This topic modeling has not been leveraged by us properly because we are not wanting to look at a particular instance or particular text that we want to see from the from the data. So we don't have anything of interest to use. So this this technique is very useful when you have something of interest and you want to research that. For example, we saw the distribution for the word corona and lockdown. You can see that the latest 20 episodes it has started these words in the speeches, and we have done for some other words also. You can perform this topic modeling when you have some words of interest or some topics of interest that you want to analyze with a speech. So our next algorithm, and this is more distribution for topic modeling, and you can see we have some keywords and we are plotting them. So our next thing is sentiment analysis. So we are using text blob for this. So in text blob we are using sentiment analysis using polarity and subjectivity. So there are many types of sentiment analysis. So the most basic one is positive and negative. So it is based on how the sentence is structured and what kind of words are used, whether the sentiment is positive or negative. So that's the basic sentiment analysis. But this won't work properly with our speeches because it'll be skewed a lot. Sometimes you'll get 100% positive, sometimes you'll get 100% negative. So you can also try using Vedar sentiment analysis, which has a few more data points like neutral and positive and negative and a few more things, but that also didn't give us any proper results. So we tried sentiment analysis using polarity and subjectivity, and we found some interesting results, even though we are not sure what exactly this means. There might be some experts who know what does polarity of a speech means. I believe this is how polarized a speech is, whether it's negative or positive. As you can see, the polarity values have come in between the range of 0 to 0.25, which means it's around the middle. It's a little more positive. So that's what you can understand from this. And the subjectivity values was between 0.4 and 0.6. As you can see, this subjectivity values lies between 0 and 1. So it is moderately subjective. So to understand what's happening in the speech, you'll need to know some context regarding that. And that was our project. Thank you for watching.